Welcome back to the Deep Dive. Today, we're taking a slightly different turn. We usually spend our time dissecting best-selling nonfiction or, sprawling articles about history or psychology. But today, we're going to look at something that is, well, it's essentially the operating system of the modern world.
Wow, that's a pretty dramatic way to put it for, what, a set of IT study notes?
Is it, though?
Hmm.
I don't think so. We're looking at a set of study notes dated January 14th, 2026. They're fresh, they're detailed, and they are specifically prepping for the AWS Cloud Practitioner certification. That's the CLF-C02 exam for those keeping score. Now, I know what you're probably thinking. I'm not a systems admin. I don't code. Why do I care about servers?
And that is exactly the trap people fall into, because this isn't really about servers anymore, is it?
Precisely. We've gone through these notes, and what we found isn't just some dry list of acronyms or, technical jargon. It is basically a cheat sheet for how modern business functions. Whether you're a CEO, a marketing manager, or just someone trying to understand why your streaming service loads instantly while your banking app crashes, you're interacting with these concepts every single day.
I think that's the right mission for this deep dive. We aren't here to help you memorize flashcards for a test. We want to decode the strategy behind the cloud. Why has the entire global economy decided to move its collective brain into Amazon's computers? What's the logic there?
Right. And looking at these notes, the learner who wrote them, let's call him our guide, is clearly trying to bridge that gap too. They've highlighted things like value propositions, architecture, and even philosophy. So let's start where the money is. The notes open with the AWS value propositions. And the very first bullet point is a financial term that usually puts people to sleep. But here, it's revolutionary. Trading fixed expenses for variable expenses.
This is the big bang moment for the internet economy. I mean, to understand why this matters, you have to look at how things used to be. In the old world, what we call on-premises or on-prem, if you had an idea for a startup, you had to deal with capital expenditure or CAPEX.
Which means writing a massive check before you've made a single dime.
A massive check. You had to find building, you had to buy industrial cooling systems, racks, miles of cabling, heavy servers, you had to hire security guards. You were building a literal data center. That is a fixed cost. You pay it whether you have one customer or 1 million customers.
And the risk factor there is just huge. If your app flops,
Then you're the proud owner of a very expensive, very warm room full of blinking lights that do absolutely nothing. You've burned that capital. It's gone.
so the notes say the cloud flips this to variable expenses.
Right. It moves you to operational expenditure, or OPEX. Instead of building the power plant, you just plug your lamp into the wall and pay the electric company. You pay only for the computing power you use when you use it.
Which effectively lowers the barrier to entry for innovation to
Basically zero. Correct. A student in a dorm room now has access to the exact same supercomputing power and infrastructure as a Fortune 500 company. The only difference is the size of the bill at the end of the month.
Speaking of bills, the notes mention a term here that I think people misunderstand. Economies of scale.
Right.
It says, users balance usage, lower costs for all. Now, usually, economies of scale just means buying in bulk is cheaper. Is that all this is?
It's part of it, but it goes deeper. AWS has hundreds of thousands of customers. Netflix, NASA, the CIA, your local pizza shop. Because they are buying hard drives, processors, and electricity at a scale that is just hard for the human mind to even comprehend, they get pricing no individual company could ever match.
So even if I'm a massive bank, I couldn't build a data center as cheaply as AWS can rent me a slice of theirs.
Exactly. It's a paradox, right? It's often cheaper to rent a Ferrari than to build your own Toyota.
I love that analogy. Okay, there's another point in this value prop section that I think resonates with anyone who's ever worked in corporate IT. The notes say, eliminate capacity guesswork.
Ah, the capacity guessing game. This used to be the nightmare of every chief information officer.
Walk us through that nightmare. Why was this such a big deal?
Okay, so imagine it's 2010. You're launching a new e-commerce site for Black Friday. You have to decide, maybe 6 months in advance, how many servers to buy and install.
And you have absolutely no idea how many people are actually going to show up.
Zero idea. So you have two bad options. Option A, you guess low. Black Friday comes, the traffic spikes, your servers get overwhelmed, and the site crashes. Customers leave, you lose millions.
A total disaster. So you go with option B, you guess high.
You buy 3 times as many servers as you think you need just to be safe. Black Friday comes, you handle the traffic fine. But for the other 364 days of the year, those expensive servers are just sitting there doing nothing. You're literally paying for air.
That sounds incredibly wasteful.
It was. The cloud solves this with elasticity and dynamic scaling. You don't guess. You provision what you need right now. If traffic spikes, the system automatically adds more capacity. If it drops, it removes it.
It breathes.
It breathes. And that ties directly into the next note here about speed and agility. The notes highlight fast deployment and experimentation.
This feels like the cultural shift.
Yeah.
In the CapEx world, the cost of failure was so high, so you naturally moved slowly to avoid mistakes.
Painfully slow. If a developer wanted to test some crazy new feature, they had to fill out a form, wait 6 weeks for a server to arrive. By then, the idea is stale. In the cloud, that developer just clicks a button. They can spin up 1,000 servers, run their experiment for an hour, and shut them all down.
And it cost them what, $10?
Maybe less. And when the cost of failure drops to nearly zero, the rate of innovation just skyrockets. That's why we've seen this explosion of software services. It's not that people got smarter, it's that the penalty for trying disappeared.
Okay, so we have the why. We save money, we stop guessing, we move fast. Now I want to get into a where, because these notes have a section on the global infrastructure map, and the numbers are staggering.
It's a massive physical footprint. It really is.
The notes list, 36 regions, 114 availability zones, 245 countries. But then it goes into some definitions that I think confuse people, specifically the difference between a region and an availability zone.
Yeah, this is a classic exam trip up, but it's also crucial for understanding how the internet stays online during, disasters.
So the notes define a region as continents or large separate geographic areas, like us East 1 in Northern Virginia.
Correct. Think of a region as a completely independent ecosystem. It has its own power grid connections, its own physical location. They're isolated. If a massive blackout hits Texas, the region in London doesn't even blink. They don't share failure points.
Okay, but inside a region, the notes say there are availability zones, or AZs, and the text here describes an AZ as 2 or more data centers. Close-ish.
Close-ish. I love that. A very scientific term, isn't it?
It's great. It says they are in the same region, but physically separated. So why close-ish? Why not right next door or totally far away?
It's a Goldilocks problem, really. You want them close enough that they can talk to each other instantly. We're talking single-digit millisecond latency. They need to sync data almost in real time.
So they can't be 3 states away.
Right. But you want them far enough apart, usually miles apart, so that if a disaster happens, it likely only hits one of them.
Like a flood or a fire or a tornado.
Exactly. If your primary data center gets washed out, you want your backup data center to be high and dry 5 miles away. That's why an availability zone is physically distinct, separate power, separate floodplains, all of it.
And the notes connect this directly to fault tolerance.
That's the whole goal. Fault tolerance just means the system keeps operating even when a part of it fails. By spreading your app across multiple AZs, you are basically insuring yourself against physical disaster.
There's one more piece of geography here, edge locations. The notes mention CDN and getting close to user. How is this different from a region?
A region is where the heavy lifting happens, the computing, the databases. But there are only, 36 of those? There are hundreds of edge locations.
So these are smaller.
Much smaller. Think of them as caches. Let's say you're in a city that's far from a region, maybe Perth, Australia. You want to watch a video hosted in the US. If every bit of data has to travel from the US to Perth, you're going to get buffering. The speed of light is fast, but it's not infinite.
So the edge location fixes this.
Yes. AWS puts a copy of that video in an edge location right there in Perth. The user downloads it from down the street, not from across the ocean. That's a CDN content delivery network.
It's like having a local warehouse for Amazon packages, instead of shipping everything from one giant factory in Seattle.
That is the perfect analogy. It's all about reducing latency.
Okay, we've built the map. We have regions, AZs, edge locations. Now let's talk about the magic of how it all runs. The notes have a section on elasticity and scaling. And there's a specific question written down here. What is scaling out versus scaling up?
This is fundamental to how you think about cloud architecture.
The notes mention horizontal scaling is the answer. But let's break down the difference, because up and out kind of sound like the same direction to me.
Sure. Imagine you own a transportation company and you have one normal sedan. Suddenly, 50 people need a ride. You have 2 choices. Choice A, you take your sedan to the mechanic and say, make this car bigger. You add a massive engine, you stretch it out, you add 50 seats.
That sounds expensive.
Yeah.
And difficult. And eventually you just can't make the car any bigger, right?
Exactly. That is vertical scaling, scaling up. You're making one resource more powerful. In the old days, we did this a lot. We bought bigger and bigger computers. But eventually, you hit a physical ceiling.
So choice B is horizontal scaling.
Choice B is you just buy 10 more sedans.
You scale out.
You scale out. You add more standard commodity machines to your fleet. The cloud is built on this principle. We don't want one giant, expensive supercomputer that's a single point of failure. We want thousands of smaller, cheaper computers working together. If one breaks, you just throw it away and spin up a new one.
And the notes mention auto-scaling here.
Right, because in the cloud, you can automate choice B. The system notices, hey, all our cars are full, and it automatically adds another car to the road. And this is the important part. When the passengers leave, it sells the car back.
That's the elasticity we talked about earlier. Now, there's another definition here that I think trips people up. Multi-tenant. The answer in the notes is, users share the same resource, but are isolated from each other.
This is the magic of virtualization.
The notes use an apartment building analogy.
It's the best way to visualize it. You and I might live in the same apartment building. We share the foundation, the roof, the pipes. That's the physical server. But I have my key, and you have yours. I can't walk into your apartment.
But what about the noisy neighbor problem? If I'm blasting music, or in computer terms, using all the CPU, does it slow you down?
In a poorly built environment, yes. But AWS uses a layer called the hypervisor. Think of the hypervisor as a very, very strict building manager. It ensures that no matter how loud I am, your apartment stays quiet. It strictly allocates resources so that my data and your data never touch, and my usage doesn't crash your app.
Safety first. Which leads us perfectly to the next section. Security and reliability. The notes list a few tools here: rollback, snapshots, replication, and WAF.
It's a bit of an acronym soup, so let's decode them one by one.
Let's start with WAF.
Web Application Firewall. Okay, so if your application is a nightclub, the WAF is the bouncer at the door. It checks everyone coming in. Are you a legitimate user, or are you a hacker trying to inject malicious code? It blocks the bad traffic before it even gets close to your servers.
And snapshots.
A snapshot is exactly what it sounds like. It's a photo of your hard drive at a specific moment in time. If you accidentally delete a critical database or ransomware hits, you can look at the snapshot from an hour ago and say, restore to this point.
It's a time machine.
It's effectively a time machine for your data.
Yeah.
And rollback, that sounds similar.
Rollback is usually for software updates. Let's say you push a new version of your website, and it turns out there's a bug that breaks the checkout button. Rollback allows you to instantly revert to the previous version that worked.
And finally, replication.
We kind of touched on this with availability zones. Replication is the automated copying of data. You write a file to server A, and the system automatically copies it to server B in a different location. It ensures that data survives the death of the hardware.
Okay, we have covered the money, the map, the scaling, the security. But the final section of these notes feels like the most substantial. It's titled, The 6 Pillars of the Well-Architected Initiative.
The well-architected framework, yeah. If the cloud world had a Bible, this would be it.
The notes list all 6 pillars: operational excellence, security, reliability, performance efficiency, cost optimization, and sustainability. But our learner here has done a massive deep dive on just one of them: operational excellence. It's an interesting choice. Most people obsess over security or cost because those are obvious pain points. But focusing on operational excellence shows real maturity. I mean, you can build the cheapest, most secure car in the world, but if you don't know how to drive it or fix it when it breaks, you're not going anywhere.
There's a quote written in the notes here right under the header. Tactics before strategy is the noise before defeat.
Sun Tzu, The Art of War.
It's heavy, but what does it mean for cloud computing?
It means that just having the tools, the tactics, isn't enough. I have a server, I have a database, I have a firewall. That's tactics. Strategy is, how do we operate this? How do we monitor it? What is our process when things break? Without that strategy, you just have noise alerts, screaming, customers complaining, chaos, and eventually defeat.
So let's look at the strategy these notes lay out. The first bullet point is organize teams around business outcomes.
This is a rejection of the old silo model. It used to be you had a database team, a server team, and a networking team, and they barely talked to each other.
They just threw tickets over the wall.
Exactly. Not my job. Talk to networking. Operational excellence says, no, you form a cross-functional team. Let's say the checkout team. They own the checkout process from top to bottom. If the checkout breaks, they fix it. It creates ownership.
Next up, implement observability for actionable insights. And the notes list 3 specific tools: CloudWatch, CloudTrail, and GuardDuty.
You need eyes and ears. CloudWatch is your performance monitor. Is the CPU running hot? CloudTrail is governance. Who clicked what button and when?
The paper trail.
Right. If something changes, you need to know who changed it. And Guard Duty is intelligent threat detection. It's looking for patterns that suggest a hack. You need all three to have observability, not just knowing is the system up, but how is it behaving?
The notes also mention, safely automate where possible.
Humans are terrible at repetitive tasks. We get bored, we make typos, we skip steps. Scripts don't get bored. If you have to do something twice, you automate it. It removes human error.
I really like this next one. Make frequent, small, reversible changes.
This is the antidote to the Big Bang deployment. In the old days, companies would save up all their updates for one giant release once a year.
And everyone would hold their breath.
And invariably, something would break. And because you changed 5,000 things at once, you had no idea what broke. The cloud philosophy is, make tiny changes every single day.
If a tiny change breaks something.
It's easy to spot and easy to reverse. It limits the blast radius of a failure.
Speaking of failure, there is a bullet point here that sounds completely counterintuitive.
Yeah.
Maximize success by driving failure scenarios.
Chaos engineering.
It sounds like you are telling me to break my own app on purpose.
I am. Because things will break. Hard drives fail, networks lag, power goes out. You want to simulate those failures on purpose during the day while everyone is in the office and drinking coffee. You want to see if your automated systems handle it correctly.
Netflix is famous for this, right? The Chaos Monkey.
Yes. They have a program that randomly shuts down servers in their live production environment. It forces their engineers to build systems that heal themselves. If you know a monkey is coming to unplug your server at any moment, you build a very resilient system. You stop relying on luck.
And the final point under operational excellence. Learn from operational events and metrics.
Never let a crisis go to waste. If something breaks, don't just fix it and move on. Do a post-mortem, a post-incident analysis. Why did it happen? How do we automate the fix so it never happens again? That is how you get better. You evolve.
So we've gone on quite a journey today. We started with the financial revolution, CapEx to OpEx.
Yeah.
We mapped the world with regions and AZs. We learned to scale out, not up. And we ended with this philosophy of operational excellence, building a culture that anticipates failure.
It really highlights that the cloud isn't just a place to store photos. It is a completely different operating model for business. It changes how you hire, how you spend, how you think about risk, the whole 9 yards.
Before we wrap up, I want to circle back to something. We talked about the 6 pillars, but we only deep dived on operational excellence. One of the other pillars listed was sustainability. The notes didn't have details on it, but combined with that Sun Tzu quote about tactics before strategy, it makes me think about the future.
It's a huge topic, a really important one.
What's the provocative thought for our listener to walk away with today?
I think it's this. In a world where we can scale infinitely, where we can spin up 10,000 servers in seconds, the question is no longer can we build it. We know we can. The engineering problem is basically solved. The real question is, should we? And how do we build it efficiently?
Just because you have infinite resources doesn't mean you should waste them.
Exactly. True architectural mastery and true cloud practitioning isn't about brute force. It's about elegance. It's about doing more with less code, less compute, less energy. That is the next frontier. It's not just about keeping the lights on. It's about making sure we aren't burning the house down to do it.
That is a great place to leave it. And to the creator of these notes, good luck with that AI test mentioned in your action items.
Yeah.
It looks like you have the foundation down solid.
Absolutely. You're going to crush it. Good luck.
Thanks for joining us on the deep dive. We'll see you next time.